Hey guys, today we're going to start by talking about something called the greatest common factor. Now last lesson you talked about what factors were, so if I were to ask you to find the factors of 6, you could say that the factors of 6 were 1 and 6, 2 and 3, -1, -6, -2, and -3. And if I were to ask you to find the factors of 8, you could tell me that the factors were 1 and 8, 2 and 4, -1 and -8, -2 and -4. Then if I were to ask you to find factors that these two guys have in common, you could say, well, they both have a 1 in common, they both have a 2 in common, they both have a -1, and a -2. Those are all the factors that 6 and 8 have in common. But then if I were to ask you to find the greatest common factor between 6 and 8, that would be the biggest factor that they both share, which in this case would be 2. So the greatest common factor between 6 and 8 is 2. Now, what's different is that you can also find the greatest common factor between variables. Let's say if I were to ask for the greatest common factor between x to the third power and x to the second power, we could say, well, x to the third power is really just x times x times x. And x to the second power is x times x. Well, if you'll notice, they have 1, 2 of these x's in common, which means that the greatest common factor between x to the third and x to the second is x squared, because x squared goes into both of those. Now, how that helps us today is they're going to be giving us polynomials, and they're going to be asking us to factor out the greatest common factor. Now, when it means factor out, that means find the greatest common factor and take it out of the polynomial so we can see what we have left. So on number 1, I have 7x plus 49. So the first thing I want to do is find the greatest common factor between just the coefficients, 7 and 49. Well, if I were to think about this for a minute, 7 only has factors of 1 and 7. Now, yes, I know that they also have negative factors, but since we're finding the greatest common factor, the negative factors will never be the biggest number that can go into anything. So 1 and 7 is where we're going to stay. For 49, my factors are 1 and 49 and 7 and 7. So the greatest number, the greatest factor that 7 and 49 have in common is 7. So that means I can take out a 7 of this polynomial. Now, let's look at the variables. My first term has a variable of x, and my second term doesn't have a variable at all. That means there's no greatest common factor when it comes to variables. All I can take out here is the number. Now, I have to figure out what I'm going to have left. And to figure out what I have left, I'm going to have to put it in parentheses after it. So currently, I have 7x and positive 49. To figure out what I have left, I take what I started with, and I divide it by what I'm taking out. So here I started with 7x, and I'm taking out a 7. So I'm going to take that 7x and divide it by 7. Well, the 7's cancel out here, and that just leaves me with x. Now my second term is 49. If I take 49 and divide it by 7, I'm going to be left with a 7. So when I take out the greatest common factor of 7, I'm left with the quantity of x plus 7. Now, if I were to give you a problem like this, 7 times the quantity of x plus 7, you would be tempted to distribute that 7, and you would end up with 7 times x, which is 7x, and 7 times 7, which is 49. And if you look, that's exactly what we started with up here. So when you factor out the greatest common factor, what it really is reverse distribution. So there should always be a way to check your answer. So let's try again on number 2. I want to find the greatest common factor between 8m and 6. So I'm going to start with just the coefficients, 8 and 6. Well, the biggest number that goes into both 8 and 6 is 2. Then I'm going to look at the variables. My first term has a variable of m, and my second term doesn't have a variable at all, so I can't factor out a variable. So let's see what I have left. If I take 8m and divide it by 2, 8 divided by 2 is 4, and the m comes along for the ride. Then I'm going to take this negative 6 and divide it by 2, and I'm going to get negative 3. So again, you can always redistribute back through to make sure you did it right. 2 times 4m is 8m, and 2 times negative 3 is negative 6. Let's look at number 3. I have 5a squared minus 15. Let's start with the coefficients. 5 and 15 have a greatest common factor of 5, because 5 can go up into both 5 and 15. Now my variables. My first term has a variable of a squared. My second term doesn't have a variable at all, which means that I cannot take out a variable. So let's see what I have left. If I take 5a squared and divide that by 5, the 5's cancel out and just leave me with a squared. If I take negative 15 and divide that by 5, I'm going to be left with negative 3. Now let's go down to number 4. So on number 4, I have 10q minus 25q squared. So again, I'm just going to start with the coefficients. If I look at the coefficients of 10 and 25, the greatest common factor that they have between them is a 5. A 5 can go into both 10 and 25. Now let's look at the variables. My first term has a variable of q, whereas my second term has a variable of q to the second power. Now, the first thing you want to look for is to make sure they're the exact same variable. It doesn't have to be the same exponent, but I have to be working with the same letter. Now, if you'll notice, q and q squared are definitely the same variable. So, I have to figure out how many I'm going to take out. And to do that, I need to think about the exponents. My first term has an exponent of 1, whereas my second term has an exponent of 2. So I have two options. I can either take out 1q, or I can take out 2q's. Well, if I take out 2q's, here I'm not going to have enough q's to give. So when factoring out a variable, you always need to make sure that you factor out the smallest number of exponents. Since I don't have 2 q's to take out on this term, I can only take out 1 q. So you factor out the smallest amount of exponents. Now let's see what I have left. So I'm going to take my first term, which is 10q, and divide it by what I'm taking out, which is 5q. 10 divided by 5 gives me 2, and q over q cancels out. Next, I'm going to take 25q squared and divide it by 5q. 25 divided by 5 gives me 5, and q squared divided by q, and if you'll remember, when we divide, we actually subtract the exponents. So 2 minus 1 is q to the first power. Let's go to number 5. On number 5, I have 8ax minus 56a. So I need to find the greatest common factor between 8 and 56. Right away, some of you might say that, well, the greatest common factor is 2. But if you think about it, 2 does go into both 8 and 56, but it is not the biggest factor that goes into both 8 and 56. We need to make sure that when we're finding the greatest common factor, it truly is the greatest common factor, not just a factor. So if you need to, you're welcome to take a second and write them out. 1 and 8, 2 and 4, and for 56, we'll have 1 and 56, 2 and, let's see here, 56 divided by 2 is going to give me 28. And then maybe I'm not sure what else goes in there. You're welcome to use your calculator. 56 divided by 3 doesn't work. 56 divided by 4 gives me 14. So 4 and 14. 5 does not go into 56 because it doesn't end into 5 or a 0. 56 divided by 6 doesn't work. 56 divided by 7 does work. 7 goes in there 8 times. So the biggest factor that they have in common is 8. So I can factor out an 8. Now let's look at the variables. My first term has a variable of an a and a variable of an x. My second term has a variable of an a. Now, here we're looking for what they have in common. If you'll notice, they both have an a variable attached, so that means we can take out an a. my first term only has or an a and an x, and my second term only has an a, which means I can't take out an x because there's not one on this term. But since they both have an a variable, I can take one of those out. Now let's see how many a's I should be able to take out. Remember, you always want to take out the smallest number of exponents. So if you'll notice, my first term, 8ax, has an a to the first power, and my second term has an a to the first power. So I can only take out an a to the first power. Now let's see what I'm left with after I factor out an 8a. So I'll take that 8ax and divide it by 8a. My 8's will cancel out, my a's will cancel out, and that'll just leave me with an x. Now my second term of negative 56a divided by 8a, negative 56 divided by 8 gives me negative 7, and my a's will cancel out, and I'm left with 8a times the quantity of x minus 7. Okay, what I'd like you to do next is pause the video and try number 6 on your own. Hopefully you found the greatest common factor between 81 and 48 to be 3, and you notice that both terms you can take out an r. So when I factor that out, I'm left with a 3r times the quantity of 27 plus 16t. On number 7, I have t squared h plus 3t. So let's start with the coefficients. My first term has a coefficient of 1, and my second term has a coefficient of 3. If I want to find the greatest common factor between 1 and 3, that might be a little difficult since one of the coefficients is 1. Well, if you think about it, the factors of 1 are 1 and 1, and the factors of 3 are 1 and 3. So the greatest common factor of 1 and 3 is just 1. Now you can factor out a 1, but it really won't do much to help or change the numbers. So when the greatest common factor is 1, we say that there is no greatest common factor for the coefficients. Now let's look at the variables. My first term has a t squared and an h, and my second term has a t. Well, since both terms have a t in common, we can take out a t. But remember, we want to take out the smallest exponent possible. The first term has a t squared, and the second term has a t to the first, so we can only take out a t to the first. Now let's see what I have left. If I take t squared times h, and I divide that by t, I subtract those exponents, and I'm only left with t to the first, and my h can still come along for the ride. Now my second term, 3t divided by t, those t's cancel out and leave me with a 3. Let's try it again on number 8. On number 8, I have a squared b squared plus a. Now if we'll notice, there's no coefficients going on at all on number 8. So we're not going to worry about them, we're only going to focus on the variables. My first term has an a squared b squared, and my second term has an a. So I want to take out the variables that they have in common, which it looks like is just an a. The smallest exponent of a is 1, so I'm only going to take out an a to the first. Let's see what I have left. If I take a squared b squared and divide that by a, I can subtract the exponents there, and I'm left with a to the first, and then the b squared can come along for a ride. Now my second term is where things can get a little tricky. Some of you might be tempted to say, well, I took out an a, so that goes away, and I'm just left with a times ab squared. But if you think about it, when you redistribute, you would get a squared b squared, but you wouldn't have anything being added on to the end, and that wouldn't get us back to what we started with. So we can't just say that a goes away. So I want you to think of the actual mathematical process behind taking this a out of my binomial. So I take the terms and I divide it by what I'm taking out. So if I start with a and I divide that by the a that I'm taking out, what is a divided by a? It's 1. So I'm left with a times the quantity of ab squared plus 1. Let's try it again on number 9. Now on number 9, I hope you notice that there are 3 terms going on, and that's okay. If there's 3 terms, it's still the same process. Let's start with the coefficients. Now the coefficients here are 1, 1, and 1, which means that I'm really not taking out any coefficients. Now let's look at the variables. My first term is an x, second term is an x squared y, and third term is an x cubed y squared. So I can only take out the variables that all 3 terms have. And all 3 terms only have an x. So let's see what I have left. When I factor out an x, I need to take each term and divide it by what I'm taking out. So x divided by x leaves me with 1. X squared y divided by x leaves me with xy, and x cubed y squared divided by x leaves me with x squared y squared. Let's try it again on number 10. On number 10, I have 3p squared r squared plus 6pr plus p. If I start with the coefficients, my first term has a coefficient of 3, my second term has a coefficient of 6, and my third term has a coefficient of 1. Since there's a 1, I can't factor out a coefficient, even though 3 and 6 have a greatest common factor, because this guy is involved in there as well. Now let's look at the variables. I have p squared r squared, p times r, and p. They all have the variable p in common, and the smallest exponent of p is just 1. So now I can see what I have left. 3p squared r squared divided by p. The 3 stays. I'm losing a p, so that goes to p, and then r squared comes along for the ride. Now, 6pr divided by p. The 6 comes along. I'm taking away that p, and then I'm only left with an r. Finally, if I have a p and I'm taking away a p, that just leaves me with the coefficient of 1. On number 11, let's start with the coefficients. So, I have 4, 16, and 12. Here they all three are coefficients that are not 1. So 4, 16, and 12. I need to find the greatest number that goes into all three of them. Well, 4 goes into 16 and 4 goes into 12. So the greatest common factor here is 4. Now let's look at my variables. A squared b squared for my first term, ab for my second term, and a for my third term. So each term has an a, and the lowest exponent is 1. Now let's see what I have left. 4a squared b squared divided by 4a. The 4's cancel out. I'm taking away an a, and that leaves me with 1a, and b squared comes along for the ride. 16ab divided by 4a. 16 divided by 4 is 4. a's cancel out, and I'm left with a b. Then finally, 12a divided by 4a leaves me with 3. One more. On number 12, I need to look at the coefficients again. 10, 2, and 14. Those are all even, so the greatest common factor here, since my smallest number is 2, is 2. Now the variables, h cubed, n cubed, hn squared, and hn. On this one, each term both has an h and an n, so we can take out an h and an n. Now let's see what I have left. 10 divided by 2 is 5. H cubed divided by h is h squared. N cubed divided by n is n squared. The next one, negative 2 divided by 2 is negative 1. H divided by h cancels out, and n squared divided by n leaves me with an n. And then finally, 14hn divided by 2hn. 14 divided by 2 is 7, and hn over hn would cancel out. The next thing we're going to talk about is something called the zero product property. And that says for any real numbers a and b, if a times b equals 0, then either a equals 0 or b equals 0, or both a and b equals 0. That's kind of a complex property, so let's talk about it. Let's say I have some number, and I'm multiplying it by some other number. Let's say that number is 7, and I get a result of 0. That means that number has to be 0. Well, what if I don't know the first number? What if I say some number being multiplied by 3 gets me a result of 0? Well, again, that number has to be 0. So the zero product property says if you're multiplying something together and you get a result of 0, one of those numbers has to be 0. So that can help us solve equations like these. On number 19, I have x times the quantity of x minus 8 equals 0. Now you might be tempted to distribute this through and get x squared minus 8x equals 0. But then we don't know how to solve it because we have an x to the second power, and we can't just add 8x, because then what do? We have an x on each side. That's not how they work. They're not like terms. So the zero product property comes into handy when we have something like this. And what we need to do is we need to look at it as two separate terms. We're going to say my first term here is x, and I can take that x and set it equal to 0. And then here my second term is x minus 8, and I can take that dude and set it equal to 0. So instead of having two small numbers, say a times b or 1 times 2, and get a result of 0, we have two terms. This dude is my first term, and this second dude in the parentheses is my second term. Well, now I have two linear equations. My purple guy is already solved. That gives me one answer. And my red guy, I can solve, so I can add 8 to each side, and I get x equals 8. That means this problem has two answers, 0 and 8. If I were to substitute them both back in, they would work. So 0 times 0 minus 8 gives me 0 times negative 8, which is 0, or 8 times 8 minus 8 gives me 8 times 0, which is 0. So that's going to help us solve equations when we have a degree of 2. Let's look at number 20. On number 20, I have b times the quantity of b plus 12 equals 0. So again, to solve, we can take this b and set it equal to 0, and we can take this b plus 12 and set it equal to 0. Now my first one, b equals 0, I don't have to solve anymore. That's already done. But my second one, I can subtract 12 and get b equals negative 12. So my answers are 0 and negative 12. Now on number 21, it looks a little bit different because I have two binomials. Now again, you might be tempted to FOIL, but if we do that, we end up with m squared minus 3m plus 5m minus 15, which has a degree of 2, and I can't solve that. So we need to use this zero product property to help us solve. I have two terms being multiplied together, and I get a result of 0, hence the zero product property. So I can take my first term, which is m minus 3, and set that equal to 0. Then I can take my second term, which is m plus 5, and set that equal to 0. Now if m minus 3 equals 0, I can add 3 to each side, and m equals 3. If m plus 5 equals 0, I can subtract 5 from each side, and m equals negative 5. So my answers are 3 and negative 5. On number 22, again, we have two terms multiplied together to equal 0. So we can set a minus 9 equal to 0, and I can set 2a plus 1 equal to 0. So if a minus 9 equals 0, we'll add 9 to each side, and a equals 9. If 2a plus 1 equals 0, we can subtract 1 from each side and divide each side by 2. Then my two answers are 9 and negative 1/2. Now 23 is where things start to get a little bit tricky, because on 23, if you'll notice, I have x squared minus 5x equals 0. I can't use the zero product property on this because it's not being multiplied together. Hence, the zero product property means I have to be multiplying the two terms together. So I need to take what we learned at the top of the page and apply it to the zero product property. I need to find the greatest common factor between these two terms and take it out. So if I look, both of these terms have an x in common that I can factor out. That's going to leave me with x squared divided by x, which is x, and negative 5x divided by x, which is negative 5. Then that equals 0. Now, using the zero product property, I can take each of my terms and set them equal to 0. And I can solve. And that gives me a result of 0 and 5. Let's see if that works again on 24. Again, I have a degree of 2 here, so let's take out the GCF. Both terms have a y in common, and I'm left with a y plus 3 equals 0. Now I can take my first term and set it equal to 0, and I can take my second term and set it equal to 0 and solve. So that gives me a result of 0 and negative 3. So the zero product property and factoring out the GCF go hand in hand to help you solve equations with a degree of 2. Now, on 25, if you'll notice, this one is not like 24 because 24 was set equal to 0. On 25, we have to get it equal to 0 before we can start to solve. So I need to subtract this 6a over to get 3a squared minus 6a, and that'll be equal to 0. Now I can look for the greatest common factor. 3 and 6 have a 3 in common. A squared and a have an a in common. So when I factor out a 3a squared divided by 3a leaves me with a, and negative 6a divided by 3a leaves me with negative 2. Now I can take my 3a and set that equal to 0, and I can take my a minus 2 and set that equal to 0. Now if 3a equals 0, we can divide by 3 and a still equals 0. If a minus 2 equals 0, I can add 2 to each side and a equals 2. So my answers are 0 and 2. Let's try it one more time on 26. First we have to subtract the 3x over, and we get 2x squared minus 3x equals 0. Then I factor out the greatest common factor, which here is an x, and that's going to leave me with 2x minus 3 equals 0. Now I take each term and set it equal to 0. X equals 0, and 2x minus 3 equals 0. Now my x equals 0 I don't need to solve, but on my 2x minus 3 I need to add 3 to each side and divide each side by 2. Oops. So I'm left with 3 over 2. So my answers are 0 and 3 over 2.